Hello and welcome to this video, Ansible Inventories. In this video, we're going to take a look at Ansible Inventories, what they are, how they are used, and the different types of inventories. We'll be seeing how we can provide connectivity as root to our CentOS hosts. We'll be seeing how we can provide connectivity to our Ubuntu hosts via sudo. We'll cover host variables, also known as hostvars. We'll be seeing how we can simplify our inventory with the use of host ranges. We'll be applying group variables, also known as groupvars, to improve the inventory further. Finally, we'll look at children groups and how these can be of use. In the previous video, we learnt about Ansible configuration files and we configured the course code repository. We're going to start using the course repository and diving into Ansible. The course content has been designed in a way so that it can be studied according to your requirements. Within each directory are a set of revisions, i.e. 01, 02, 03, and these will gradually change as we progress through the course material. These have been set up in a way so that each directory is self-contained and is a fully working example. On the left-hand side, we have the I'm here for the ride reference. This is the easiest and quickest approach. Quite simply, you can follow each revision in the same way that we show in the course, and you can execute Ansible in your lab against the revisions. You can edit these files and you can play with them as you go along, and you'll always start with a known working example. If, however, you're looking for a more hands-on approach, and find that you learn in a better way through creating the examples yourself, this is where the fully hands-on approach comes into play. There's a template directory which will have a base set of skeleton files, and that will be the bare minimum to get started. You'd start in this directory and you'll update each file as we go through each revision. This approach takes longer and is more prone to error, but has the benefit of being hands-on. If you do get stuck, you can also refer to one of the revisions and see what is different. So let's get started in the course repository. Change to our lecture directory as follows. You want to go into the Dive into Ansible, Ansible Architecture and Design, and into the Inventories folder, and here I'm starting in 01. Depending on which approach you actually go for, you can either start here in 01, or you can start in the template directory. Let's just check that our host CentOS1 is pingable. Now just Control-C that. In this directory, we have the following files. Firstly, if we have a look at our Ansible config, we have a default section, and within this we're specifying our inventory with the value of hosts. This is going to be a file name called hosts that is relevant to the path. If we take a look at the hosts file, this file is structured using the ini format, which, if you're interested, can be read about here on this Wikipedia page. It's a very simple format and will become self-explanatory as we go through this. We have a group of all and an entry for CentOS1. Technically, here we don't need to add the all group, as every host is automatically assigned to the all group in Ansible, regardless of which group it is in. For now, we've structured it so this is defined. In case you still have it, let's remove the known hosts file. So with this set, we can now try and execute an Ansible ping against the all group. At this point, it won't work as expected, but we'll work through this anyway. For now, we'll just Control-C this. Ansible is attempting to connect to the remote host using SSH. It's not aware of the target's fingerprint, it's waiting here for user input. It's possible to ignore the host key check with the environment variable Ansible host key check-in equals false. We can quickly test this out by placing this variable before the command we wish to execute. This is a useful Unix tip where you want the variable to be specified for a single command only. In the background, this would have recreated our known hosts file. Whilst this environment variable is convenient, we wouldn't want to remember to set it every time. So, to make this permanent, we can add an entry to our Ansible configuration file. If we go to revision 2, and we take a look at our Ansible configuration file, you can see that we've got an additional entry here. The host key check-in equals false. Let's just remove our known hosts file again. And we can try our Ansible all-m ping, this time without the environment variable set. We can see we've got success there with no user interaction. Within our lab, we've got a mixture of hosts using both CentOS and Ubuntu. Let's take a look at revision 3. And if we look at our hosts file, you can see that we now implicitly have both a CentOS and Ubuntu group, and we've added all of our CentOS and Ubuntu hosts. As you'll recall, all hosts are automatically added to the all group by default, so if we try and ping using the all group, it works as expected. But this time, we're actually going to be pinging all 6 of these hosts. We can now also target our implicit groups. So for example, CentOS and Ubuntu. It's worth noting that this can also be referred to with the wildcard symbol. You do, however, have to quote it, otherwise it's seen as a listing of files. So for example, the output at present takes up a lot of our screen estate. The -O option for one line will give us a condensed view which can be useful in these scenarios. The inventory that we have so far can be queried with the Ansible tool. So for example, we can list all of the hosts in the CentOS group. We can list all of the hosts in the Ubuntu group. We can list all hosts. We don't even have to specify a group. We can use the individual hosts here. This also applies to where we're working with modules. So, for example, and here we specify the -m and ping for the ping module and -o for one line. It's also flexible, allowing us to use this with pattern matching. So the tilde indicates matching a pattern, and here we're using regular expressions. In a regular expression, dot means any character. Star follows this as any number, so we have any number of any characters, and then ending in free, which gives us both CentOS free and Ubuntu free. Excellent. So at this point, our inventory looks like the following. This is good progress. However, Ansible isn't going to be able to do a lot with the level of user access that it has on the remote hosts. Ideally, we would need Ansible to have escalated access, i.e. root privileges. When we set up our SSH keys earlier, we configured it so that we could also connect from our Ansible system to the remote systems as the root user. Let's make use of this for our CentOS hosts. To do this, we're going to use a hostvar, i.e. a host variable. Step into revision 4. And if we take a look at our hosts file, we can see in this example the Ansible_user host variable to the right of the host name set for each of the CentOS hosts. stating that the user we will use is root. On previous versions of Ansible, this entry was Ansible_SSH_user. The best practice now is to omit the _SSH. Let's run a ping against this with the one-line option. Okay, so that appears to be successful, but we can't really confirm 100% from this view that it's now using the new user. So we're going to switch to a different module outside of the ping module, and we'll use this to check our ID on our system. Right now, if you run ID, you'll see the Ansible user alongside your UID and GID details. We can use the Ansible command module to run this command on our remote host using Ansible with our inventory. The module is command and the argument is ID, i.e. run the ID command. So you can see the CentOS ones have UID equals 0, which is the root user, and the Ubuntu ones still have Ansible. Our Ansible inventory now looks like the following. Although it's convenient in our lab environment to have direct access as root to our systems, it's more common in the real world to restrict direct root access. We would therefore be expected to connect to our hosts as mortal users and then to escalate to a super user. Fortunately, Ansible has us covered on this as well. And if we move into the revision 5 directory and take a look at our inventory, we've specified the Ansible become as true, i.e. become a super user, and we've specified the Ansible password, which is required if the Ansible user on any of the Ubuntu systems was running sudo. Let's check that this still works as expected. And we'll run our ID command again. This time we're going to omit the -m command and just pass the argument for ID. As the command module is so useful, it is the default module that Ansible will use. So now we've got UID equals 0, meaning the root user for all our Ubuntu and CentOS hosts. Our inventory now looks like the following. All of our systems are running the SSH daemon on port 22 as standard. However, systems can run SSHD on alternative ports. What if, for example, CentOS 1 was running SSHD on port 2222? Let's set this up. If you go to your terminal where you're running our lab and press Ctrl+C, then edit your Docker Compose YAML file. Find the section for CentOS 1. And what we're going to do here is swap the images so we have an image which has SSH configured on 2222 rather than the default. Okay, and if we save this file and we run our Docker Compose up, and then go back to our lab environment and log in again, and we go back to revision 5, and now if we retry our ping command, you can see that we get failure as expected, as Ansible is expecting to communicate using port 22, the default port for SSH. If we now go into revision 6, and we take a look at our inventory file, we've added another variable to the CentOS 1 host specifying a particular port to use for Ansible. If we run our ping command again, this all works as expected. A slight variation on this is in revision 7. Open up the inventory file, and you can see here it's possible to specify the port as you would with SSH, i.e. a colon and a port number. This again works as expected. After these changes, our configuration now looks like the following. We have all of the standard hosts using 22 for SSHD, and CentOS 1 is using 2222 as its SSHD port. Move into revision 8, and if we take a look at our hosts file now, we've added in a control group and we've specified the Ansible connection as local. Therefore, no transport mechanism like SSH is required. If we give this a try, you can see we've also got the inclusion of Ubuntu-C in our inventory. Let's go into revision 9. In our hosts file, we had commonality between all of the Ubuntu hosts and respectively the CentOS hosts across Ubuntu 1, 2 and 3 and CentOS 1, 2 and 3. We can simplify this using ranges. If we take a look at the hosts file, we've broken this down so that we're using CentOS 2:3 and Ubuntu 1:3. We've had to make an exception here for CentOS 1 as that is different, as it's using a different Ansible port. But for all the others, they share commonality, and we can make use of ranges. Let's check that this is working as expected. Recall the list host option of Ansible. We'll run this against the all group and verify. Great. All of the hosts are still available, and we can see that the inventory is improving as we move through each revision. If we bring up the inventory file as it is, we still have duplication in the CentOS group, where we have Ansible_user defined for both CentOS 1 and the range of CentOS 2 to 3. We can mitigate this through the use of groupvars, making every host in the CentOS group automatically receive the hostvar of Ansible_user. We'll also do this for the Ubuntu group. Let's take a look at revision 10. You can now see these two extra sections, CentOS::vars and Ubuntu::vars. Within this, we've added the specific hostvars for Ansible_user equals root and Ansible become with Ansible become pass. With this in place, each CentOS host will receive the CentOS group vars and the Ubuntu hosts will receive the respective Ubuntu group vars. We try this out with a ping. Excellent. All is still working as expected. Before we move into the next revision, let's recap our hosts file. You can see here we have a mixture of Linux hosts, i.e. CentOS and Ubuntu 1 to 3. It would be good to distinguish these into a collective group, as both of these are variations of Linux. Fortunately, Ansible has a children declaration, which is useful for this, where we can define a parent group of Linux with both CentOS and Ubuntu as the children. Go into revision 11, and bring up our hosts file. And you can now see this at the bottom. If we ping the Linux group, it will automatically inherit the CentOS and Ubuntu group. Let's go into revision 12. If you recall, we talked about the all group, and technically all hosts are part of the all group, and we can use this knowledge to apply variables to all hosts using the all vars group. If we take a look at our hosts file, You can see here that we've set the Ansible port to 1234, which is an invalid configuration, as our hosts are either running on port 22 or, in the case of CentOS 1, port 2222. What's useful to know is that specific host entries take precedence overall. So, where we have the Ansible port specifically set for CentOS 1, this will take priority over the all group. Therefore, if we ping Linux now, all will fail with the exception of CentOS 1. If, however, we were to ping all would fail with the exception of CentOS 1 and Ubuntu-C, as that uses the local connection. Step into revision 13 and take a look at the hosts file. We can also apply groupvars to a parent, and again all children will receive the vars, but as per the all group, host-specific hostvars like the one we have for CentOS 1 still take precedence. Going forward from this revision on, we're going to remove this section. The inventories that we've looked at so far have been in the ini format, but they can also be written in YAML or JSON. If we take a look at our Ansible config, you can see there that this is specifying hosts.yaml. If we take a look at our original inventory, this is the equivalent file in YAML. In YAML, a file can be defined with 3 dashes and 3 dots as the start and the end. Whilst this isn't strict, and you'll see YAML files without this, we are following this specification throughout the course. We have our groups at the root of the indentation, and under these we have keywords. So, hostvars in this case for groupvars, and in the case of Linux we have children. Individual host variables are indented under each host. In our later videos, we cover YAML in greater detail, so for now, if this is new to you, don't worry. If we try our ping command across all hosts, it should still work as expected, in the same way as it did with the ini format. Move into revision 15. We can also take a look at the JSON equivalent, as we have our file in YAML already. Converting this to JSON is pretty simple, and the following Python one-liner achieves what we're looking to do. This command tells Python that we want to execute the statements given as a command in quotes. We're importing our modules sysyaml and JSON. The JSON.dump method will be taking the input we're reading, this YAML coming from standard input. We're using an indentation of 4, and we're finishing our command and redirecting the output to a file called hosts.json. Let's take a look at our file. JSON is a lot more stricter than YAML, and you'll note that the hosts have to be defined as null values. Lastly, the Ansible config is updated to reference hosts.json. And again, if we execute our ping, our inventory as a JSON file is still working as expected. And here we've put our Ansible config to point back at our standard host file. In both of the previous examples, we changed our Ansible config, and the inventory was updated to point at hosts.yaml or hosts.json. We could have also used the inventory command to override this behavior by specifying the corresponding inventory with -i. If we were to do this, Ansible would automatically detect the inventory format of ini, YAML, or JSON. Another command line option to be aware of is the -E for extra vars. This can also be used to override existing variables in the inventory. So for example, Ansible_port in our inventory file. We have CentOS1 that has an Ansible port set of 2222 to work with our changes to the SSHD server on that host. We can use the extra vars parameter to override this. If we provide Ansible_port equals 22, it will apply this host var to every host in our inventory. Let's try this out against the Linux group, as we know CentOS1 is listening on port 2222 for SSHD. Therefore, this should fail. Correspondingly, if we inverted this and we set the port to 2222, CentOS1 will work and all of the others will fail. Okay, brilliant. I very much hope you enjoyed this. Please join me in the next video, Ansible modules.